All right, so first things first, we're going to talk about circumference. What does it mean to like circumnavigate? Like if you circumnavigate, what are you doing? Joe?
Going around the globe.
Going around the globe, right? It's the same thing with circumference. You're just going all the way around the circle, okay? It's the distance around the outside of the circle. So the distance around a circle. Okay, anybody know the formula for circumference off the top of their head? No? So we have two of them, okay, but they're really related. The first one is circumference equals 2 pi r, okay? R is the radius, and as I said, c is circumference. So pi is just a number, right? Okay, what is 2 times the radius?
The diameter.
The diameter. So that's our other formula. We have circumference equals, I think we write pi for, yeah. Circumference equals pi d. D standing for diameter.
Mr. Wayne, let's talk about this pi deal. What is pi?
3.141.
Okay, it's 3.14. That's the abbreviated version of it. Pi actually never ends. It's an irrational number. It goes on forever and ever and ever. How did people discover pi?
Someone was trying to make a cake.
Almost. Maybe. Here's what they did. Back way long ago, people started making the connection between the distance around something, the circumference, and the radius, okay, or the diameter. And if you take the circle, okay, and or the circumference, excuse me, if you take the circumference of a circle and you divide it by the diameter, you will get this number, pi. 3.14159, so on and so forth. And it doesn't matter if the circle is this big, or the circle is this big, or it's the Earth. Okay, if you take the circumference of that circle, divide it by the diameter, it's this special number called pi. So that's kind of where it comes from, and that's why it's used to calculate it. So some people just kind of get confused, like what is it? Pi is 3.14. Let's talk about that on our calculator. Where's that at on our calculator? Second caret. Where's it? Second broccoli. Where's caret at?
Under
Right under clear. That little arrow is called the caret key. So there is pi. Go ahead, Mr. Martin.
Elizabeth?
Go ahead.
Oh. Okay, so let's try to find the circumference then using one of those two formulas. So if they give us the radius, it's probably easiest to use the first one, right? So find the circumference if the radius is 9 centimeters. So we're going to set that up. C for our circumference equals 2 times pi times our radius, which we said is 9. Okay. Multiplication is commutative, right? So can I switch the order there? I can say 9 times 2 times pi, which is 9 times 2 is 18, right? So circumference equals 18 pi. So if they ask for the exact answer, that's what you're going to give them, 18 pi. Okay? When they say exact, they want it in terms of pi. So you're kind of treating pi like an x or something like that, okay? Now, you can also give an approximation. So that would be 18 times pi. Does anybody have that in their calculator?
56.55.
56.55.
Guys, and I'm a big believer in being as accurate as we can. If we have a button for pi, 3.14159, blah, 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 let's use it instead of 3.14. It won't change your answer drastically, but if we're using pi in a larger calculation, it could. Okay? Guys, why in the blue there, Mr. White put 18 pi? Why is that exact? He says exact versus rounded. Absolutely. Guys, we had to round 56.55, didn't we? 18 pi is exact. There's no rounding involved there.
Okay. So on the next one, find the circumference of D. Our diameter is 32 feet. Which formula do you want to use? First, second? Second. Okay, so we're going to have C equals pi D. We said we can take D out, substitute in our 32. Okay. So our exact answer is going to be 32 pi. It's kind of standard convention to write the number first, then pi. Okay. How about approximation? What'd you guys get?
100.53.
100.53. Awesome.
Wait, what is 100.53?
That's circumference.
We say feet. Feet, circumference is all the way around, right? So 100.53 feet all the way around this particular circle with a diameter of 32 feet.
Okay, let's work backwards now. So let's find the diameter if the circumference is 17 feet. How are we going to set that up? Christopher?
Diameter equals 17 divided by pi.
Diameter equals 17 divided by pi. How'd you get that? Whoops.
Well, Mr. Bull told us earlier that it's the same thing if we were going backwards. So,
Okay. So if we start with our original equation here, right, we have 17 equals pi d, okay? And then you divide by pi to get d by itself, right? Yeah? Divide by pi. All right, and that's how we got there. So that would be our exact answer. How about an approximation? Does anybody have that? 5.41. Awesome. And what's our units here? Feet. Okay.
Is that 5.4?
5.41 feet. $5.41 feet. Okay. Okay. So find the radius if c equals 34 pi. Okay. Joe?
Would it be 17?
Let's see. Okay. So how'd you set that up?
I just did 34 divided by 2 because it's pi times r times 2.
Okay. So our circumference, we're looking for r. So our circumference is 2 pi r, right? And that equals 34 pi. So then you divide by 2 pi. Is that what you said, basically?
Yeah.
Okay. Divide by 2 pi. Divide by 2 pi. When you do that, it's just like if those were x's, right? If you have an x divided by an x, you can cancel it out, right? Or if you have 3 divided by 3, you can cancel it out. It's the same thing here. Pi divided by pi is just 1. So you can cancel that out. Then you have 34 divided by 2, which is 17. So our radius is 17.
Guys, on every single one of these, what did we do?
Divided by
On all 4 of these. We set up the equation and plugged in what we knew. On the first 2, we probably either knew our diameter or our radius. Excuse me, yes, diameter or radius. On the bottom 2, we knew our circumference. So we filled in for the circumference and either solved for our radius or our diameter. Set up that equation every single time. All right, now this next part, we're talking about arc length. Now we just got done with a chapter all about circles, and we talked about arc a lot. Now arc was always the measure of the arc, wasn't it? It was always in degrees, okay? Well, arc length is not in degrees, all right? So if we say arc, or the measure of an arc, it's degrees. If we say arc length, well, that's in a linear measure, centimeters, feet, miles, whatever it may be. Okay, so the arc length is if I look at my picture, if I want to find the length of this arc, let's say AB here, okay, that is a portion of the circle. Would you agree? And really, that's a portion of the circumference. So if I look at my picture, and it's not very good in yours because yours is black and white and gray, and I have the color. This red part of the circle, would you guys agree that that is just a part of the circumference?
Yeah.
Okay, that's just a part of it. Okay? Now, our formula is this. It is theta. What does theta represent again? An unknown number, yes. Theta usually represents an angle. Okay, so in this example, this would be theta. It's our unknown angle measure. That's a part of the circle. Okay, so theta over 360. Now, if you stop for a minute and think about that, theta is an angle. It's a portion of the whole entire circle, which is represented by 360. So I have a portion or a part over the whole entire thing. Okay? And that is going to equal L, which is going to represent our arc length, over our circumference. What did I just create there? A proportion. All right? So the angle over the entire thing, so the part over the whole, needs to equal the part over the whole. In my mind, I think that makes sense, doesn't it? The angle, which is the part of the whole entire circle, that ratio here needs to be equal to the ratio of this part of the circumference over the whole entire circumference. Okay, now, what's our formula for circumference? Pi d or 2 pi r. Thanks for participating. So C could either be 2 pi r or pi d in our formula. Okay, so I may not put a C in my formula for these next few problems, but understand the circumference is either one of those formulas. So I may put a C in there, I may replace that with 2 pi r, or I might replace that with pi d. All three of those things essentially the same thing and are interchangeable. Okay, so again, every single one of these, we're going to start with our formula. So I'm going to say, we don't have a lot of room here, guys, so you might need to write small. Theta over 360 equals my arc length over my circumference. All right, and this problem's asking us, all right, it is asking us to find the arc length of arc AB. So we want this red part of the circle. Well, what do we know? We know theta is how much? 60. And we know my radius is 8. So I'm going to put 60 over 360 equals the arc length. Well, that's what we're trying to find, so I'm going to keep an L there, over my circumference. Now, my circumference, I'm given the radius, so I'm going to say 2 times pi times my radius, which is 8. Now, if you want, does this reduce? Because you don't have to do this, but you surely can. Guys, anytime you have a fraction and both of them end in a 0, you can cancel those things. Magic, I know. And so then I'm left with 6 over 36. Does that reduce? That's just 1/6. Again, you don't have to do this. You could have kept it at 60 over 360 and gotten the same answer that I'm going to do, but it just, as a math teacher, it kind of bothers me to keep things like that a little bit, and I won't always do that, but I just kind of felt like it here. And the arc length is over my circumference. What's 2 pi times 8? 16 pi. Okay, so now I can solve this proportion. Remember, here's my variable. I go across from it. I take 1 times 16 pi divided by 6. Guys, I would do 16 times pi, hit enter. Divide by 6, hit enter.
So 6 times pi.
16 times pi Enter, divide by 6. What do we get there, guys? 8.38. Do we agree with Elizabeth there? What does that mean? It tells us the length of arc AB. It tells us the length of that particular portion of the circle. Okay, now, this next one, we're asking for the circumference of the circle. Okay, so the two things that we're given theta, which is 40, right? Right? And we're given the arc length, which is 4.19. So I'm going to go back to my formula and plug in what I know. So theta over 360 equals my arc length over my circumference. So theta is 40. So 40 over 360 equals the arc length, which is 4.19 over the circumference. Now, should I put 2 pi r here or pi d?
Pi d, because you don't know.
Or c?
C.
We're asking for the circumference here, aren't we? So let's just put c here. Now, if it was asking for the radius, what should we put in there? Probably 2 pi r. If we're asking for the diameter, put pi d in there. If they're asking for the circumference, let's just put circumference. Okay, so here's an example where I could reduce that. You don't have to. This time I won't, just to show you. But there's what I'm trying to find. Go across from it. 360 times 4.19, hit enter. Divide by 40, hit enter. What do we get there? 37.71 inches. How are we doing out there?
So then you would just solve out like any other proportion then?
Absolutely. Once we set it up, solve it like any other proportion. Okay, now, same idea here. Theta over 360 equals arc length over circumference. What are we given here, guys? Well, let's figure out what we're trying to find. We're trying to find the measure of arc RS. In our formula, what is that? That's theta. We don't know the angle. We don't know the angle that is. Now, would you guys agree with me that looks close to, somewhat approaching 180 degrees? So we're anticipating something around 180 degrees. Okay? So we don't know theta, but I should know my arc length. If I don't know theta, I should know my arc length and my circumference. So I'm going to keep theta in my problem. What's my arc length? 15.28? 44, okay? So I think this represents my radius. In this, since it's here, is representing my arc length. Okay? So this would be 44. Yep, 44. Over my circumference. Is that 15.28?
No, it's 2.
Oh, so this is the radius, right, guys? So I better go over here and put circumference equals 2 times pi times my radius. I'm running out of room, which is 15. Circumference equals 2 times pi times my radius, which is 15.38. So I better first find my circumference before I can use that in my formula. So 2 times 15.38, what's that, 30.76?
It should be 2.8, not 3.8.
Oh, 2.8, not 3.8? 30.56 times pi, right? What do you get there?
I got 96.
96.01?
Yeah.
Oh, okay.
So we have to find our circumference first, and now we can go from there, solve it as normal. Go across from our variable here, 144 times 360, hit enter, divide by 96.01. 164.98. I would be okay with that. I think the book actually has 165, so if it asks to the round of the nearest degree, we'd call that 165. So this would be in degrees. Questions, comments, concerns on that? All right, next page, please.
All right. So who's ever used one of those like slap bracelet things? Do you know what I'm talking about? Yeah? Okay. So on this problem, we're talking about how far a tire travels, right? It's kind of the same idea as one of those slap bracelets. So if it's rolled up, right, like end to end, not overlapping, if you hold the end, one end of it and unroll it, does it change its length at all? No. So the distance that you travel when you roll it, if it's end to end, is going to be the same as it laid out, right? So like if I draw a little circle here, right? Let's just say that's the point that I grab and don't let go. And then I start to unroll it. It's going to look like that. And it's going to look like that. All three of those are the same, right? Okay? So it's the same idea with the tire. So a tire travels, that circumference, right, the distance around the tire, that's one revolution. Okay? That's how far it's going to go for every time that tire turns one time. Okay? So to the nearest foot, how far does the tire travel when it makes 15 revolutions? So we're going to have to take that distance around times 15 times that it went around, right? Okay, so how do we find the distance around it? Yeah?
5.5, 15, 5.5 to all the way around the tire.
So that's our diameter, right? It's kind of confusing from the picture, but this is saying that like this 5.5 is the distance from the rim to the top of the tire. 15 is how big the rim is, and then another 5.5 to the bottom of the tire. Okay, so that's going to be our diameter. 15 plus 5.5 plus 5.5. And you should get 26. Yep. So the diameter of that tire is 26 inches. Okay? Now we know how to find the circumference, right? We have the diameter. So our circumference of the tire is going to be pi d. We said d was 26. So circumference is going to be 26 pi. So that's one revolution, right? So if you start, hit the gas, and then brake as soon as the point that was touching the ground touches the ground again, that's one revolution, right? So how much do we have to times that circumference by to get 15? 15. Okay? So the total distance traveled is going to equal 15 times our circumference, which is 26 pi. How much is it? 390 pi. Okay? So look back at the instructions up there. Do you think they want it in terms of pi, or do they want it in terms of feet? What do you think? Feet, right? Okay, so we need to approximate that. It says up here to the nearest foot. Okay? So it doesn't say like in terms of pi. It says to the nearest foot. So 390 times pi is 1,200 what? 25 point. Okay. Is that feet or is that inches though? What was our diameter in? Inches. So how are you going to get to feet from inches? Divide by 12, exactly. So we're going to take this, divide by 12, and that's going to give us 0.1 feet. 102.1, that says field, that says feet. Cool. Anybody have any questions on that? All right. So I need you guys to write in something for me on this next one. I got kind of cut off on the printing job. So down here, next to this little line here, write a 2 in. Okay? So we want to find the perimeter of this shaded region. Okay, perimeter is the distance around, right? So I know that this big part here and this big part, because of our lines, right, those are congruent, so they're both 6 inches, right? So I'm going to start my perimeter over here. I'm going to say 6 plus 6. So that takes care of this part and takes care of this part. Okay, if I go down now, we wrote in that 2, right? Does it have something that matches it on the other side? Yeah, it does, right? Right here. So my green parts here, there, and here are both 2. So I can add those in too, right? Plus 2, plus 2. Okay, so now I have this part that's 6, that part that's 6, and then these 2 parts. The only other part I have to find the distance around that curved part. How am I going to do that? Chris?
All of those curves add up to 360 degrees or a full circle.
That's an interesting way to do it. Okay. So all of those curves add up to 360 degrees. Okay. How are we going to find the distance around that circle? The circumference. Okay. So what do we need that we don't have right now to figure out that circumference? The radius. Okay. Look at this side. It says that's 6 units long, right? Okay. We know that this middle part, the green part here, is going to be 6 minus, or sorry, the green part, the middle part is 2, right? So we know that those pieces of that circle have to add up to 4, right? The radius across it. So we know that our radius, right, if our center of our circle is, whoops, I missed, right there, that radius, right, that distance up, has to, that plus the one on the bottom, has to both equal up to 4, right? Okay? So if one radius plus the same thing again equals 4, what is the radius? 2, exactly. Okay? So we have our full circle, which is 360 degrees, okay? And then we have our radius, which is 2. So 2 pi times 2. So circumference is going to be 4 pi. So I need to add that on here at the end. So plus 4 pi. So our perimeter total, we'll put this in terms of inches. You can approximate it. What'd you guys get?
28.57.
Can you say that again?
28.57.
28.57? Is that what you guys got? Awesome. So the perimeter around this figure is going to be 28.57. What's our units again? Inches. Awesome. Anybody have any questions on that one?
Here's a couple things here. This is 12, right? 12 and 4, that's 16. Can I call that 20 pi? Because 16 plus 4 is 20 pi. No. This has a pi to it. These do not. Mountain Dews, Pepsis. Okay, I see that a lot where they just go, hey, I'm going to add everything together. Well, that has a pi to it. This does not. So let's convert that. Let's plug that in because these don't have pi's. Okay, guys, we have a couple problems on our assignment that are similar to this. Okay, break the circles up separate than the other parts. Find the circumference or find a part of the circles that make up the perimeter and go from there. Okay, hang with us. Last example, our last thing here. Now, there are many ways to measure different things. How do we measure degrees, as in temperature? Thermometer, yes, we measure it in degrees and Celsius if you're in a different part of the country. All right, if you go to Europe, are they going to use feet and inches? No, they're going to use centimeters, meters, kilometers, okay? So there are many ways to measure different things. Well, with angles, that's also true. So instead of measuring something in degrees, we can also measure in radians, okay? So a radians are just another way to measure angles. Okay, now, I want you to think about something. If I had a circle, and let's say the radius was 1. The radius is 1. What's my circumference? Wouldn't it be 2 pi? The circumference of a circle with a radius of 1, the circumference is 2 pi. Okay? So to get a radian, what we do is basically break up a circle into different parts in terms of 2 pi. So all the way around the circle in 360 degrees, that means 2 pi. Okay? So what's half a circle? That's just pi, isn't it? So 180 degrees is just pi radians. So we can have an angle in degrees or radians. All right? So we're going to be converting today between degrees and radians. All right? Here's our formula for degrees to radians. It is the degree, or the degrees, times pi over 180. We just got done saying that pi, okay, is 180 degrees. Raise your hand if you had Mrs. Gantz. Well, in the past she calls it physical science. Raise your hand if you had physical science. Okay? Not a lot. Raise your hand if you've done unit conversion in Miss Gantz's class. Not a whole lot. Okay. Normally that's what she hits. Okay? Over here, this is going to be radians times 180 over pi. So if I am converting from degrees to radians, here's my formula. I'm going to take 45 degrees times pi over 180. So, I can multiply these and get 45 pi over 180. Guys, we do not want a decimal here. Okay, if it's in radians, radians are always going to be in fractional form. So we need to reduce 45 over 180. How many times does 45 go into 180? 4 times, right? So I can take out a 45 from here, and I'm left with 1. If I take a 45 there, I'm left with 4. So what am I left with on the top here? 1 pi. I'm just going to call that pi over 4. So a 45 degree angle in degrees is called pi over 4 in radian measure. Okay, now if we're going to convert from radians to degrees, well, I'm going to take my radians, which is 3 pi over 2, and I'm going to times that by 180 over pi. Now, guys, I have a pi in my numerator, a pi in my denominator. What's going to happen to my pi's? They're going to cancel, aren't they? Well, if you think about it, in the end, I want degrees. Degrees doesn't have a pi in it. That's why they cancel. That's why that works out. So I can take 3 times 180. What's 3 times 180? 540 and divide it by 2. (270 degrees). So 3 pi over 2 in radian measure is 270 degrees